interference testing. Interference testing is a multiple well testing. Multiple well testing means the test run between two sets of perforation or test interval in same well to determine the properties in the vertical direction. This interference testing is conducted by producing from or injected into one of these valves, which is the active valve. And the pressure response is observed in the other valve, which we call it observation valve. Active valves start producing at uniform pressure when the time is equal to 0, and other pressure response in the observation valve at distance r from active valve after some time. As shown in the figure below, this is the active valve and this is the observation valve. And this radius of interference can be calculated by this formula. With K is equal to the permeability, and T is the time, this is the porosity, this is the viscosity, and this is the total compressibility. The function of this interference testing is to determine whether two or more wells are in pressure communication in same reservoir. If the communication exists, this testing can provide estimate of vertical formation permeability, which is the K, and the porosity, and the compressibility product. This because for homogeneous isotropic system, the porosity, permeability, and thickness are the same everywhere and in all directions. While for the heterogeneous system, numerical solution used to analyze the pressure transient data. This testing is very important and useful because it can understand the well behavior in a water flow and enhance oil recovery project.
So now we start with the interference test function. But before that, Union already explained about how it works, but I'm going to go through again. So imagine this is the well, this is the active well, and the other one is the observation well. Okay. So what we do is, we're going to inject something inside the active well, and then we'll see the difference if anything happens on the observation well. We want to know either these two wells is connected or not. So basically this test, interference test, is done and designed to give a large scale in reservoir property. Okay. Other than that, is also to improve the estimate of direction of permeability, K, and the reservoir storageability. Okay, so basically the functions are, first, we want to know either these two well is connected or not by their permeability and their grains. So I'll show you a little bit of the drawings. Imagine this is two well. This is the formation. You'll have a lot of grains in between, right? So if we inject water from here, let's say it's water. So we want to know is either the water flow into another observation well or not. If it's flow, if we detect any flow, then we know that these two are connected. And that means this can be the injection well later on. And other than that, we also want, by interference test, we can know the flow pattern. Is it the turbulence patterns or laminar flow? Laminar flow. Okay. And we also want to know the reservoir property, whether these reservoir properties is it the same or not. And the last one is the nature and magnitude of isentropic directional reservoir permeability, like Union had mentioned before.
Okay, so guys, we finished the introduction and this theory part, and I am now going to talk about the applications of the interference testing analysis. Actually, for the interference testing analysis, we have two cases. Case number one is when we have active well is producing or injecting. The pressure behavior is given by this formula, which is BWS equal B at 1 hour plus M, which is the slope, and log T. And it's this equation, we will call it equation 1, and it is valid only when 0.000267 kT over porosity multiplied by viscosity Ct r squared, and this part much be more than 100. So at that time we can use this equation. Okay, and now we have to plot the graph of BWS versus the time on a semi-log graph. Okay, and that will give us a slope which will be a straight line. That slope, we can use it to bring the K, which is permeability. We can calculate it like that, 162.6 Q viscosity P over mH. Guys, we have now the K over the mu Ct r squared. We will multiply it by the exponential of Bi minus B at 1 hour over M, which is the slope, minus 3.2275. So we can get the porosity. Okay, and of course we will get the P1 hour from the semi-log straight line at T equal 1 hour. Okay, and for case 2, it is happen when active well is shut in after producing for time which is TP, time of production. So the equation of calculating the pressure behavior is BWS equal Pi plus M log function of Tp plus delta T over delta T. And now our turn again is to plot the graph between the two functions, which is BWS versus the Tp plus delta T over T, delta T graph. Then from that graph we will get a straight line, will lead us to calculate the slope, which is M, and we can calculate the K and the porosity. How we can calculate the K and we calculate the porosity? Like that. K equal 162.6 Q viscosity over P over mH so we can get the K. And we can also calculate the porosity from K over mu CT R square exponential of function P1 at 1 hour minus BWS over M minus log 1 plus 1 over TB minus 3.2275. But don't forget that we calculate the P1 hour at T equal 1 hour, and we calculate the BWS at delta T equal 0. Okay, so we can get, here is the two cases that I explained to you. We have in case one active well is producing or injecting, and the other case is the active well is shut in after producing for time. Thanks.
Hello everyone. I think you are understand what well interference test. To make it more clear, I have one simple example that will make clear your concepts. As you can see that we have recorded interference test for a 40 hours at a distance from 190 feet away from the active well, and we recorded the data for these time periods. So by using the interference test, we can find permeability and porosity of the giving data. We have all the data here in which we have the viscosity of the fluid, formation volume factor, CT, Q flow rate, initial pressure, thickness of the reservoir, and the radius of the reservoir with the depth. So when we want to measure the porosity and permeability, the first step is we will get the interference data. As you can see at the 0.0 hours, we had the pressure is 0 psi. After the 4.3 hours, we have 22 pr, and in the end we measured the maximum for 2 days, that is given at the given value, that is at 119.1. So our next step is we will plot a graph between delta P and T. T will be on the x-axis and P should be on the y-axis. And we must remember that we are using log graph here. So after that we will get our points on the graph paper. Our first point is like here, and this time you should remember our graph should be similar like the original graph which I am showing you here. So we will get the similar curve here after plotting the above points. So then we will select a simple convenient point, called it matching point. This point should be any point near to the curve. It should be it depends upon you how you will take this point after the matching the curve. Then we will get the 4 values. Our first value is delta P from the plotted curve. Delta P we will get from the plotted curve, not from the original curve. And then we get T from our curve that we make it from here on the y-axis. Our next value is the T from the dimensionless time from the master curve, which is this curve. We will just consider draw point here, and then we take it down from the y-axis. And the second step we will take T from this curve. As we get all the 4 points which were required to us, we got dimensionless pressure and the delta P from the master curve and from the graph which we plotted. Then simply we will put in want to calculate the permeability. We will simply plug all these values, all other values parameters are given, and the values we put it here, and we got 5.1 millidarcy. At the same time, when we use the dimensionless time and the time from the matching curve and from the original curve, we plug these values in this equation in order to find porosity. As all other parameters are given in our data which you have seen earlier, we will just simply plug these values, and by using the calculator we will get the final answer, which is 1.14 into 10 raised to power minus 6 psi porosity.
Okay. Hi everyone. Now we will look into the development of multiple well testing. Okay, as we mentioned before, we have 2 types of multiple well testing, which are first, the interference well testing or the interference test. Next one is the pulse testing. Okay, pulse testing is actually the advanced technology of the interference test. Okay, so let me explain to you what is the pulse testing. Okay, so we have here two types of tests, which is the interference test and also the pulse test. Okay, the first test is the interference test. So we have two wells in the reservoir, which first well will be the injection well, the second well will be the observer well. Okay, the injection well will be producing all the oil, or injecting all the oil, and the observer well will check on the pressure to check on the continuity of the wells between the reservoir. And then we have the pulse test, which the first well will still inject the well, be the injection well, and the second well will be the observer well. But in this pulse test, it will be shut in as a process. So it is called as pulse test because due to the shut in process. Okay, this shut in process will open and close the well to check on the pressure differences between the well. Okay, why do we have this pulse test? This pulse test is two. First, it will require a short time due to the shut-in process. Then you will have also less interpretation due to the shut-in process. And lastly, because of the shut-in process, the pressure reading or result will not be affected by the outer boundary conditions during the interference testing.